Number 9, Spring 2012, final exam, cart's acceleration and X direction. So everything's given here on the diagram. And we are told that the free body diagram and kinetic diagram are required. Um, so let's go ahead and do that first. Okay, so I'm going to isolate, obviously, I think, the cart, and then draw the forces on the cart. The inclines, sort of what makes this difficult, but let's go ahead and draw this force right here. Okay, it's 15 pounds. We also have a normal force perpendicular to the incline and a weight going straight down. Alright, we're going to come back to these angles in a second. And we're going to have some sort of mass times acceleration vector in this x direction. So we're going to use a coordinate system parallel and perpendicular to the incline. So let's see what our angles are here. Okay, the incline is 30 degrees right here. So the angle between the normal and the weight is 30 degrees. So that one's pretty easy. Okay, this 15-pound force right here is 20 degrees off of, I'll write that in here, 20 degrees off of the incline, and the incline is 30 degrees. It doesn't matter what the incline is because we're using that, going to base things on this x direction here. Okay, so that 20 degrees is exactly what we need. Alright, so in the x direction, we're going to say sum of the forces in the x is equal to mass times acceleration in x. And that gives us the equation 15 cosine 20. Okay, that's going in a positive x direction, this component that's adjacent to the incline, or parallel to the incline. But we also have a weight component that's going in the negative x direction. So we're going to have minus w, and it's going to be the sine of 30, going back in the other direction. And that's going to be equal to mass times acceleration. Alright, I'll go ahead and plug numbers in. Okay, so my weight was 40. And so my mass is going to be 40 over 32.2 times acceleration in the x direction. Wow, that turned out to be pretty easy. One equation from the free body diagram, accounting for all the forces. We're given everything we can need to calculate a sub x. Oh, let's see, about right there. Alright, so I'm just going to calculate this side, multiply by 32 and divide by 40. 15 cosine 20 minus 40 sine 30 times 32.2 divided by 40. And that's not the right answer. Let's double check. Okay, double checking my equation that I had here. Get my calculator back over the way, out of the way. It looks like I typed something in wrong. It should have been 15 cosine 20 minus 40. I had a 4 there, sine 30. Okay, so that would have been a simple math error. We're really looking for this equation, and then the just the math to get there is a small part of the problem. But if I do second enter, go back and insert a 0 right there, I'll get that number, and then I'll multiply by 32.2 and divide by 40. Okay, minus 4.75. The units are going to be feet per second squared. We're working in English, and we had pounds, and feet per second on our G term there. Okay, what does this mean? This means that it's actually slowing down. That the weight component right here going back down the incline is larger than the 15 cosine 20 going up the incline, so this thing is tending to slow down. But all we're asked for is the acceleration. And there it is.